Hi, I'm Larry Johnson. I am a professor here at Texas A&M University, and today we're going to talk about the liver, the gallbladder, salivary glands, and the pancreas. We'll be talking about the objectives, features, functions, origin, distribution of epithelium, liver functions, the lobules, capsule, portal area, bile canalicularis, and hepatocytes.
And here we can see in this body world's rendition of a female and male, you can see the diaphragm here, and there's the liver, the pancreas in through there, the stomach would be in there as well, duodenum, liver, gallbladder. We can see the different organs associated with the digestive tract. Our objectives are to understand the general organization of these accessory organs of the digestive system and how they contribute to obtain metabolites necessary for growth and energy for the body. We want to learn the origin of these glands and how these structural features of these glands contribute to their function of digestion and absorption of food stuff. And here we can see the organs that we'll talk about. The liver, and you can see the classical lobule of the liver, the gallbladder, which is associated with the liver on the side, salivary glands located at the top, and the pancreas. Those are the ones that we're going to study. Start out with, we'll have the salivary glands, liver, gallbladder, pancreas that we'll talk about today. Now, the function of the digestive tract is to move food, secretion of digestive juices, and absorption of foodstuff, and the accessory glands contribute. A salivary glands lubricates things for things to slip down. Also, the salivary gland and the pancreas secrete digestive juices, as well as the liver secretes a bile for emulsifying fats and getting rid of cholesterol. Liver stores nutrients and it cleans the blood. It also is associated with digestive organs that contribute antibodies and antibiotic viral growth substances to prevent infection, as the digestive tract has to maintain a milieu in the body that is different as pure a state as possible. Now, the origin of the digestive tract is the endoderm. You got the digestive tube, as well as the liver, pancreas, gastric glands, and intestinal glands. They come from the endoderm. And here we can see the endoderm coming through, giving rise to the lungs, as well as it gives rise to the stomach, and a outgrowth of the gallbladder, and even the liver, and the pancreas as well. So you can say that most of the organs associated with the GI tract, as well as the GI tract, come from endoderm, and you can see how one pipe gives rise to the other organs. And so we have the salivary glands, we have the liver, the gallbladder, and the pancreas that we'll be talking about today. One of the most important glands, of course, is the liver. It filters blood. It has a lot of Kupffer cells, which are macrophage type cells. They're monocyte origin of the cells, and they filter the blood. There's also stored blood in the sinuses. It maintains normal glucose concentrations by regulating uptake of glucose, or the breakdown of glycogen and glucose maintains a certain normal level to help maintain homeostasis and metabolism and transport of lipids. And it secretes plasma proteins, clotting factors it does, and nutritional metabolism of bile, drug metabolism, drug tolerance. The smoother you are can clear the drugs. If you're giving someone like anticonvulsant drugs, for example, you have to keep giving a patient more and more of them because the liver clears them. Also, it produces bilirubin, and bilirubin in your blood makes you jaundice, and it secretes bile for emulsifying fat. So the liver does a host of different things, very important for its contribution to the digestive tract. And here we can see this is a classical lobule. We can see it here in a pig. The pig is good because it's got connective tissue around the classical lobule, and a classical lobule has a central vein. So blood is coming in from these portal radicals and through this area and percolates down into the central vein that we can see. And so here we can see on a pig liver, we can see the classical lobules, one right here, one right there, and it has a central vein in the center, and it's separated by connective tissue you can see in between. So this is a classical lobule, not a classical lobule. And also the liver has a capsule. Sometimes it's fairly thin, sometimes it's fairly thick. But in either case, it has a mesotelium lining the cavity. Here we can see some of the cells. These are hepatocytes. This monkey liver, and these are Kupffer cells that have phagocytizing. Here we see blood cells. Now the liver has a couple of functions. It acts like an endocrine organ. Also, it acts like an exocrine organ, and you can see it secretes glucose, plasma proteins directly into the blood like an endocrine organ, but it also secretes bilirubin as an exocrine organ as well. This dual role of these is important for compartmentalization of these endocrine exocrine-like products. The liver has to have certain architectural makeup, and hepatocytes is arranged in a fenestrated. You can see a column through here, anastomosing and anamosing columns of one thick layer with a sinus on either side. And so you can have two sinuses, and also you can have the bowel canaliculus in between. Here we can see the bowel canaliculus in yellow, and then those drain into a bowel duct that you can see here in green. And then you see the cords of cells, and you can see the sinuses that runs between the cords of cells. So the hepatocyte has to have contact to the sinuses, as well as a way to keep the bowel separated from the blood. And here you can see the portal radical. You have portal vein coming from this. This is your hepatic vein coming in from the small intestines. There's a bile duct, and there's a hepatic artery bringing oxygenated blood in through here. So the blood comes from here, percolates down through there by these hepatocytes, and then finally out through the central vein. So you may have different surfaces of the hepatocyte. You do. Here you can see one to interact with a blood sinus on one side, and an interact with a blood sinus on the other side as well. In addition to that, it has a bowel canaliculus on either side. So this one has four surfaces, two for exocrine, and then two for endocrine as well. And here we can see the hepatocyte has lots of mitochondria through the rough ER, smooth ER, glycogen stored. But here you can see the two surfaces. This is a sinusoid where the blood's up through there, and then this is where the bowel is discharged in the exocrine function.
We want to acknowledge the original source of images, drawings, and figures that might have been taken from various textbooks. We want to acknowledge these textbooks in this presentation. This is the end of the liver, gallbladder, salivary glands, pancreas. That is objective, features and functions, origin, distribution of epithelium, liver function, portal area, canaliculus, and hepatocytes.